Okay, inverse function notation. So, if f of x is a one-to-one function, then its inverse function is written as f of negative 1 of x. So basically, once you find the inverse of that function, we can write it as f of negative 1 of x. Okay, and it's not to be confused with f of x to the power of negative 1, which is the reciprocal, okay? So in other words, if the negative 1 is with the f, then it is the inverse, whereas if everything is to the negative 1, then that is the reciprocal. Because remember, this is the same as 1 over f of x, okay? So that is not equal to 1 over f of x, okay? So they are two different things. Okay, so with that being said, that is the notation that we use to identify what the inverse function is. Okay, so each composite of the function and its inverse sends every number for which it is defined back to itself. So basically, if you've got the function and an inverse function, if you put a number in, so let's say you put 3 into the function and it produces 7, then if you put 7 into the inverse function, then it'll give you the number that you started off with, so 3. And it works whichever way you do it. Okay? So, each composite of the function and its inverse sends every number for which it is defined back to itself. So f of negative 1 of f of x is equal to x, because the number that you put in brings it back out again. Okay, and f of negative 1 of x is also equal to x as well. And the domains, so the domain for the first one is just the original function, the domain for the second one is just the original function as well. Okay, an identity function is a function, I of x, whose output is the same as its input. So I of x is equal to x for all of its domain. So basically, if you put the number 3 into it, and then it gives you the number 3 back, then that is a identity function. So a very common identity function is just f of x is equal to x. Because basically, if I put any number into that function, it just gives me the number back out in return. Okay, it's not the only one, but that's probably the most simple one. Another identity function is like f of x plus 1 minus 1. Okay, so it's the same as f of x, but, you know, it's another identity function that produces the same thing. And there's more than just those ones, but those are the ones I can think of the top of my head. Okay, so to find f of negative 1 of x, so to find the inverse from f of x, so you convert it into y is equal to notation. So basically, if you have a function that looks like this, so f of x is equal to x, okay, what you do instead is you just rewrite it, but instead of f of x, you write it as y is equal to x, or y is equal to whatever it is. Okay, so instead of f of x, so f of x goes to y. Okay, so once you do that, you then write y for x and x for y in all equations and conditions. So basically, you know, if your function becomes y is equal to x squared minus 3, then what you're going to do is you're going to rewrite all of the x's as y's and all the y's as x's. So x would become y squared minus 3, okay? So basically the idea is that you're rearranging, or you're replacing all the x's with the y's and with all the y's with the x's. Now let's say, for example, you know, so here's your function. You've got f of x is equal to x squared plus 2 when x is greater than 4, okay? So now when you're going to do this one, what you're going to do is you're going to replace f of x with y. So you've got y is equal to x squared plus 2 when x is greater than 4. Now to write the inverse, we replace all the y with x's and all the x's with y. So here's a y, so we replace that with x. X is equal to y squared plus 2, where y is greater than 4. Okay, and I'm pretty sure we did this in the last one as well, but just as a quick reminder, that's how we write the inverse. Okay, so we're replacing all the x's with all the y's, just like that. Okay, and then the last step back over here is solve for y and convert back to the notation f minus 1 of x is equal to y. So basically what you're going to do in this is you're going to solve for y. So we'll ignore this bit on the right here for a moment, and we'll just focus on the left bit. So get rid of all that, and we'll continue on with this one. So x is equal to y squared plus 2, so we're going to solve this for y. So it becomes x minus 2 is equal to y squared. So y is equal to the square root of x minus 2. Okay, and then to just change it back, you just replace the y with the new inverse function notation x, f of -1 of x is equal to the square root of x minus 2. Okay, so basically all you're doing is replacing and solving. That's it. There's no tricks to this. So sometimes when a function is many to one, that is, the inverse is not a function, it is often convenient to restrict the domain of the function so that the new restriction function has an inverse. So just as a quick example of that, let's say you had a circle, so x squared plus y squared is equal to 4. Okay, so this is a circle with radius 2 around the center. Okay, if you replace the x's with the y's in this one, you get y squared plus x squared is equal to 4. So the inverse is the exact same as because you just rearranged it around, it's the exact same as the original function. But what you can do then is, well, you can say, let's restrict it so when x is greater than 0. So we're only doing, the top bit of that circle there, okay? So you might want to just restrict it just to make your function, your inverse function of your function really, or so that it becomes a function, I should say. So the circle is obviously not a many-to-one function, it's a many-to-many function. So it wouldn't quite work for that one, but that was just a general one I could give off the top of my head. Okay, so let's look at the first example. So find the equation of f of minus 1x of each function, and then verify that so basically you're doing your composite functions to prove that it's equal to x, so that it is the what's the word I'm looking for? It is the inverse. So what we're going to do is we're going to write out our function, so f of x is equal to 2x minus 6. Then I am going to replace the f of x with y, so it becomes y is equal to 2x minus 6. And then I'm going to solve this, then I'm going to swap these around, so then that becomes x is equal to 2y minus 6, like that. Okay, and then I'm going to solve for y. So x plus 6 is equal to 2y. Okay, so then y is equal to divide everything by 2, so it is x plus 6 on 2. Or y is equal to x on 2 plus 3. Okay, to finish it off, I just need to rewrite it with f of -1. So f of -1 of x is equal to x on 2 plus 3. Now I need to show that, or need to verify that f of -1 of f of x is equal to x, and the other way around works as well. Okay, so we're going to start off with, verify. So we're going to do verify f of -1 of x is f of -1 of f of x is equal to x. Okay, we'll do that one first. So f of -1 of f of x, so f of x is 2x minus 6, and that's equal to, okay, so we're going to put it into this equation up here. So it becomes, replacing the x with 2x minus 6, so 2x minus 6 on top of 2 plus 3. Now this should give me x if I simplify it out. So 2x minus 6 divided by 2 is x minus 3, plus 3 on the end. Minus 3 and a plus 3 cancel, and I'm left with x. So that one works, so we're happy with that one. Then we need to verify the next bit. So that's verify f of x. Oops, sorry. I keep stuffing this on that. F of f minus 1 of x. Okay, so what I'm going to do is I'm going to replace f of minus 1 of x with the function that I came up with, which is x on 2 plus 3. Okay, so wherever I see a x in my initial function, so remember, my initial function, f of x, is equal to, 2x minus 6. So in this function, wherever I see an x, I'm going to replace it with x over 2 plus 3. So I get 2 lots of x over 2 plus 3. Okay, and then minus 6 on the end. Okay, so 2 multiplied by all that, so it's going to cancel with the bottom, so that's 2 times half of x, it just becomes x. Okay, plus 2 times 3, which is 6, minus 6. So 6 minus 6, well, that's just equal to x. So therefore, f of minus x equals to x over 2 plus 3 is the inverse of f of x equals to 2x minus 6. Okay, so that's part one. And that was just, just following those steps. So that's all you need to do is just follow those steps. So let's do part B down here. And that equation is, or that function I should say, the function for that one is f of x is equal to 2 minus x cubed. Okay, where x is greater than, is less than or equal to 0. Okay. So what we're going to do for this one is we're going to start off by rewriting f of x as y is equal to 2 minus x cubed, where x is less than or equal to 0. Okay, then we're going to swap all the x's with y's and all the y's with x's, so it becomes x is equal to 2 minus y cubed, where y is less than or equal to 0. Okay. So then we're going to rearrange this equation on the left for y. So we're going to start off by subtracting 2. So we get x minus 2 is equal to negative y cubed. Okay, so to get rid of the negative, so y cubed is equal to 2 minus x. So that's changing that to plus 2 and that changing that to minus x. And then just swapping them around. Okay, and then I'm going to do the cube root. So the cube root of 2 minus x, where y is less than or equal to 0. Okay, so when is this function? Okay, so we've got y is equal to 3 square root, cube root, y is equal to cube root of 2 minus x, but we've got this restriction for where it's y. We need to find where the restriction is equal to x. So basically what we're going to do is we're going to find what value of x makes this true. So when y is less than or equal to 0, where is the x? So the way we're going to do that is if we've got y is equal to this thing up here, and we've got y is less than or equal to 0. Okay, so it means it has to be true in both cases. So because y is equal to this, I can just substitute it into that equation and then solve it for the x to find that value there. So in other words, so y is less than 0, so the cube of 2 minus x, I should write over here, finding the restriction. Okay, so the cube root, so y, because this is y here as it says, and that needs to be less than or equal to 0 according to this restriction over here. Okay, so this is to find the restriction of x. Okay, so to do this, I'm going to say, well, what's the cube root of both sides? Okay, well, that removes that. And, well, the cube root of 0 is just 0, so 2 minus x is less than 0. So minus x is less than, well, I take the 2 across, it becomes minus 2. So x must be greater than or equal to 2. So therefore, my inverse function of x, so the inverse of 2 minus x cubed, where x is bigger than 0, is where f of negative, or where is the inverse when it is equal to the cube root of 2 minus x, okay, where x is greater than or equal to 2, okay? So because the inverse back up here, because the function back up here only works when x is less than or equal to 0, okay? So we know that it only equals, it's only true when it's x less than or equal to 0. It means that the function itself, or the inverse function itself, okay, only works when x is greater than or equal to 2. So it's just a little bit of algebraic manipulation to work out, well, what is that value that makes it work for the inverse. Okay, now we need to verify it. So just to verify it, all we need to do for this one is just substitute those values in. So we're going to do f minus 1 of f of x first. Okay, so f minus 1 of, so f of x is equal to 2 minus x cubed. Okay, so 2 minus x cubed. So looking back down here, okay, f minus 1. So wherever I see an x in this function here, I'm going to replace it with 2 minus x cubed. Okay, so it's the cube root of 2 minus, now this is where the x is, so I'm going to replace it with 2 minus x cubed. Okay, now the reason I'm doing that is Well, because I've been told to, so I shouldn't say the reason I'm doing that. So now what I'm going to do is, I'm going to simplify this right-hand side. So here's a negative, so it changes everything in here to be the opposite. Okay, 2 minus 2 becomes 0. So I get the cube root of x cubed, which is just equal to 1. Okay, not 1, sorry, equal to x. Okay, so you know, if you have 4 cubed, then the cube root of that, well, that's just equal to 4. Okay, something like along those lines. So that's just equal to x. So that one works. Okay, and then we're going to verify the other one. So we need to verify f of x. Oops, sorry, f of negative 1 of x. Okay, so now to verify this one, well, that just implies that f of, okay, so this one is the cube root of 2 minus x. Okay, so to rewrite that, we're going to write it as, so my original function is 2 minus x cubed. Okay, so 2 minus, so this thing cubed, so the cube root of, whoa, what's going on there? The cube root of 2 minus x, all cubed. Okay, so 2 minus, so the cubing a cube root just makes it so it becomes like that. Okay, cubing a cube root. Okay, now with the negative on the outside, it just changes all the stuff on the inside. So 2 minus 2 plus x, and therefore it's just equal to x like that. So that one works for that one. So verify and verify. So therefore, just to finish it up, therefore the inverse of f of x equals to 2 minus x cubed is f negative 1 of x is equal to the cube root of 2 minus x, like that. Okay, so that's those two functions there. Okay, a lot of working out for those two questions, but it's relatively easy. It's just a process that you need to follow. Okay, so we'll have a look at example number 2 now. Now, these ones are a little bit trickier, but again, it's just the same process. So, write down the inverse relations for each function. If inverse is function, find the expression for f of minus 1 of x, and verify that f of minus 1 of f of x is equal to x. And so it's the same as before. So we'll start off with a. So f of x is equal to 1 minus x over 1 plus x. Okay, so rewriting the f of x as a y. Okay, so y minus x over 1 plus x. So it's the relationship, okay, instead of a function. And now we're going to write, we're going to swap all the x's with the y's. So x is equal to 1 minus y over 1 plus y. Okay, so now I would suggest that you pause and have a go at trying to solve this for yourself, doing some algebraic manipulation. But if you just want to watch how it's done, then the way we're going to do this is we're going to start off by multiplying everything by 1 plus y. Okay, so that gives me x lots of 1 plus y is equal to 1 minus y. Okay, then I'm going to expand the left-hand side. That's going to give me x plus xy is equal to 1 minus y, just like that. Okay, then I'm going to move the y to the other side, so it's going to give me x plus xy plus y is equal to 1. And I'm going to move that x back over. So I'm going to get xy plus y is equal to 1 minus x. Okay, now I'm going to factorize this side because I've got a y that's common to both. So y, lots of x plus 1 is equal to 1 minus x. Okay, then I'm going to divide both sides by x plus 1. So it's going to give me y is equal to 1 minus x over x plus 1. Or alternatively, y is equal to 1 minus x over 1 plus x. Okay, and you'll see why I did that in a moment. Okay, so now to change it back to the inverse function, so therefore f of 1 of x is equal to 1 minus x over 1 plus x, like that. Okay, so the reason we've done that one, or done it like that, you'll notice it's actually the same is what we started with. So the inverse is the same as the original function. So 1 minus x over 1 plus x, 1 minus x over 1 plus x. So we need to verify it now and make sure that it is the inverse. So to verify it, okay, f of x, nope. Okay, so f of f minus 1 of x, we'll do this one first. Doesn't matter which one you do first, because you're going to have to check both of them anyway. So it's 1 minus x on 1 plus x, and we're going, whenever we see an x, we're going to replace it with 1 minus x over 1 plus x. So we've got 1 minus x, 1 minus x over 1 plus x. Okay, over 1 minus x over 1 plus x. Okay, so doing this one, we're going to start off by, okay, rewriting the one on the top as, or let's split it up into two parts. So 1 minus x over 1 plus x. And now that's going to be divided by 1 minus x over 1 plus x, like that. Okay, now I'm going to rewrite these with both over 1 plus x, so it's going to become 1 plus x over 1 plus x minus 1 minus x over 1 plus x divided by, and the same again, so 1 is the same as 1 plus x over 1 plus x minus 1 minus x over 1 plus x. Like that. Okay, now we can subtract these together. So we've got 1 minus 1, which is equal to 0. X minus x becomes 2x. So we get 2x over 1 plus x divided by, okay, and for this one it's going to be exactly the same. So 2x over 1 plus x. Okay, so 2x divided by over 1 plus x divided by 2x over 1 plus x. Well, that's just the same as saying 5 divided by 5 or 8 divided by 8, or, you know. So this is just equal to 1. So, with that one being said, oh, we want it to be equal to x, don't we? So, well, let's actually expand this out, or do it the long way. So, to solve this, we're going to go 2x over 1 plus x divided by 2x over 1 plus x. So that's the same as 2x over 1 plus x times 1 plus x over 2x. So remember doing the reciprocal. So to divide two fractions, divide by the reciprocals. Okay. And what we're going to do now is we're going to put these together. So we're going to get 2x lots of 1 plus x over 2x lots of 1 plus x. Okay. And, well, you can see now that the top is going to cancel and the bottom is going to cancel like that. So again, it just leaves us with 1. So it doesn't actually leave us with x in this case, it leaves us with 1. Now, from memory, when you put these two in like that, or I should say when you put a function inside itself and you get an answer of 1, it means that all the values, no matter what value of x I'm going to be putting in, I'm going to always get a value of 1. Now, if you go back to the beginning of the video when I was talking about the identity, okay, the identity function. So it was whatever number I put in, I get a number out in return. This is a little bit different because it doesn't actually come out as x. It actually comes out as 1 itself. So in other words, what it's saying is it doesn't matter what number you put into this function, okay, you're always going to get the value of 1 back in return. So I'm going to leave it at that for now. I'm not going to verify the other way because it's literally the exact same calculation. Okay, it's going, oh, I know what I've done. I've done 1 plus, I've done 1 minus instead of 1 plus. That's annoying. So if you go through, it should work out to be x. So let's quickly fix that up. So 1 plus on that one. Okay, so that should be a plus there. So that should give me, instead of giving me that, it's going to actually give me 2. Okay, so it's going to be 2 times x. So it will give me, So the 1x is still going to cancel, but it'll be 2x divided by 2, which will leave me with x. That makes more sense. That's better. So that one itself gives me the x back in return. Okay, so I would do it again for the other part, but it's not going to make a difference because it's exactly the same calculation. Okay, because you start off with the same function and you put the same function into the same function and give you the exact same calculation. So what we can say then is therefore f of x is equal to 1 minus x on 1 plus x is, well, f of negative 1 of that is the inverse of f of x is equal to 1 minus x over 1 plus x. So a bit trickier, that one, a bit trickier. Let's move on to part B. So part B for this one says that we are going to now do the same thing, but this time f of x is equal to 9 minus x squared. Okay, 9 minus x squared. So for this one, we're going to start off by changing f of x's to y. So y is equal to 9 minus x squared, like this. I'm going to swap the x's and the y's around, so like that. Okay, now we're going to do some manipulation to get the y by itself. So move the 9 across, becomes x minus 9 is equal to negative y squared. So y squared has to be equal to 9 minus x. Okay, so it's getting rid of the negative, swapping them around, and swapping the 9 and the x around. Okay, and then to get rid of the square, we're going to take a square root. Okay, and so that's my inverse function. Like that. So f of negative 1 of x is equal to the square root of 9 minus x. Now to verify this one, we will have to probably do both because they aren't the same function this time. So we're going to start off by verifying f of negative 1 of f of x. Okay. So f of negative 1 of, so f of x is 9 minus x squared. So wherever I see a x in this equation or in this function down here, okay, so that one there, I'm going to replace it with 9 minus x squared. So square root of 9 minus 9 x squared, okay, like that. So simplifying this one out, we're going to get square root of 9 minus 9 plus x squared. Okay, the 9 and the positive 9, they're going to disappear again. Okay, just like before. So we're going to be left with the square root of x squared, which is just equal to x. Okay, so that one works. Now we need to verify the other one. So f of x, f of negative 1 of x. Okay, f of negative 1 of x, which is equal to, I'll write it down here. So we're going to write that as f of negative 1, which is the square root of 9 minus x. Okay, which is equal to, so wherever I see, so going back to my original function, 9 minus x squared, wherever I see an x, I'm going to replace it with square root of 9 minus x. So f, I don't want an f there, I just want the, okay, so 9 minus square root of 9 minus x, all squared. Okay, so the 9 is going to stay there, the minus is going to stay there, the square is going to get rid of the square root, so I'm going to be left with 9 minus x. Okay, now removing that bracket, I get 9 minus 9 plus x. 2 9s cancel out, I'm left with x. Okay, so therefore f of x is equal to, f of negative 1 of x equals the square root of 9 minus x is the inverse of f of x is equal to x squared plus 9. Sorry, 9 minus x squared. Don't know where I got it from. 9 minus x squared. Okay. So that's pretty much it for this one. Okay, so this is going to be the last topic that we're going to do in functions for a little bit. We're going to look at parametric equations at a later date, after we do trig and fact, which will be our next topic. But with that being said, that means that the first extension topic for now is complete.